Welcome. Today we are talking about reference frames, one dimensional, two dimensional and three dimensional. Let's talk about one dimensional coordinate system. One dimensional coordinate system means number line. It's a line, so it can be extended infinitely from the both ends. 0 is in the middle of the line and positive integers are in the right side of the 0 and negative integers are in the left side of the 0. When we move right side from 0, integers gradually increase. When we move left side from 0, integers gradually decrease. So plus 10 is bigger than plus 5 and minus 10 is smaller than minus 5. Natural number means counting numbers 1, 2, 3, 4 and so on. Whole number means 0, 1, 2, 3, 4 and so on. That is all natural numbers together with 0. Integer means 0 plus minus 1 plus minus 2 plus minus 3 and so on. That is 0, positive integers and negative integers all together are called integers. Rational number means a number of the form p by q where p, q are integers and q not equal to 0 and GCD of pq equal to 1. Fractions are belong to the rational numbers. Rational number means finite decimal numbers and infinite recurring decimal numbers. Irrational number means infinite non-recurring decimal numbers and square root of prime numbers. Real number means rational numbers and irrational numbers. Complex number means a number is of the form x plus iy, where x and y both are real numbers and I is equal to root over of minus 1. Now we talk about two-dimensional coordinate system. Horizontal axis or x-axis and vertical axis or y-axis are perpendicularly intersected by each other at origin whose coordinate is 0, 0. Right side of the x-axis from origin is positive, left side of the x-axis from origin is negative, top side of the y-axis from origin is positive, bottom side of the y-axis from origin is negative. So we get 4 quadrant. In the first quadrant both x and y coordinate are positive. In the second coordinate x coordinate is negative, y coordinate is positive. In the third quadrant both x and y coordinate are negative, and in the fourth quadrant x is positive and y is negative. The point A 4, 3 is in the first quadrant because its both coordinate is positive. The point B minus 5, 2 is in the second quadrant because its x coordinate minus 5 is negative and y coordinate 2 is positive. The point C minus 6 minus 4 is in the third quadrant because its both coordinate x and y are negative. The point D 5 minus 3 is in the fourth quadrant because its x coordinate is positive and y coordinate is negative. X coordinate means perpendicular distance from y axis and y coordinate means perpendicular distance from x axis. So the perpendicular distance of the point 4, 2 from x axis is 2 units, that is its y coordinate. The points 2, 3, minus 3, 1 and minus 1.5, minus 2.5 are on the first, second and third quadrant respectively, and 0, 0 is the coordinate of origin. After calculating we get coordinate of the point A is 2, 3 and coordinate of the point B is minus 5.5, minus 1.5. Position of the point 5, 0 is on the positive x-axis and position of the point 0 minus 3 is on the negative y-axis. Distance between the points P1 x1 y1 and P2 x2 y2 is equal to root over of x1 minus x2 whole square plus y1 minus y2 whole square. Equation of x-axis is y is equal to 0. Equation of y-axis is x is equal to 0. Y coordinate of any point on x-axis is 0. X coordinate of any point on y-axis is 0. Now we talk about 2D polar coordinate. Here fixed line is called initial line and fixed point is called pole. Theta or phi measured in anti-clockwise direction. Small r or rho is distance of the point from pole. Here x is equal to r cos theta and y is equal to r sin theta. Conversely, r is equal to square root of x square plus y square and theta is equal to tan inverse y by x. To locate a point on xy plane we need two coordinate, but in polar coordinate we need only one coordinate, either theta or small r. We calculate another by its curves equation. It's the main advantage of the polar coordinate over the Cartesian coordinate. Let's talk about rotation and translation of Cartesian or rectangular coordinate system. In rotation, we rotate the axis at an angle theta in anti-clockwise direction. In translation, we shift the origin at the point hk without rotating the axis. So small x is equal to capital X plus h and small y is equal to capital Y plus k, and x dash is equal to x cos theta plus y sin theta and y dash is equal to y cos theta minus x sin theta. Let's take few problems on translation and rotation. Please pause the video and go through to the solutions. The complex plane or argand plane is the plane formed by the complex numbers with a Cartesian coordinate system such that the horizontal x-axis, called the real axis, which is formed by the real numbers, and the vertical y-axis, called the imaginary axis, which is formed by the imaginary numbers. The polar form of a complex number z is equal to x plus iy with coordinate xy is given by z is equal to r e to the power I theta, where minus pi less theta less or equal to pi. In three-dimensional space, the Cartesian coordinate system is based on the three mutually perpendicular coordinate axes called x-axis, y-axis and z-axis. The three axes intersect at the point called the origin 0, 0, 0. One can imagine the origin being the point where the walls in the corner of a room meet the floor. The x-axis is the horizontal line along which the wall to your left and the floor intersect. The y-axis is the horizontal line along which the wall to your right and the floor intersect. The z-axis is the vertical line along which the walls intersect. The parts of the lines that you see while standing in the room are positive portion of each of the axes. The negative part of this axis would be the continuations of the lines outside of the room. In 3D coordinate system, straight line means intersection of two planes and a point means intersection of three planes. 2D Cartesian plane consists of 4 quadrants and 2 axes. Similarly, 3D Cartesian space consists of 8 octants and 3 axes. In spherical coordinate system, the coordinate of the point P, B, rho, theta, phi. Now the coordinate rho or small r is the distance of the point P from the origin. Let Q be the projection of the point P on xy plane. Then theta will be the angle between positive x-axis and the line segment from the origin to Q. Lastly, phi is the angle between positive z-axis and the line segment from origin to P. Where rho or r greater equal to 0, theta ranges from 0 to 2 pi and phi ranges from 0 to pi. Cylindrical coordinates are a natural extension of 2D polar coordinates in 3D space. These coordinates combine the z coordinate of 3D Cartesian coordinate system with the polar coordinates in the xy plane. In physics and mathematics, the concept of a fourth dimension is often used in theories such as string theory, superstring theory, M theory, Einstein's special theory of relativity about space-time, where higher dimensional space are used to describe the universe and fundamental particles. These theories propose that there may be more than three spatial dimensions, means length, breadth, and height we are familiar with, and the additional dimensions play a role in shaping the universe at the most fundamental levels.